Howdy and welcome back. Today's exercise is Freelancer Rates. We'll be implementing a few functions to quickly calculate daily and monthly rates and with a given discount. Freelancer Rates is a noticeable step further into Elixir. In previous exercises, we've seen only our own module and functions. This exercise introduces us to the kernel and float modules. And if you don't know what those are, then I need to introduce you to the documentation. In Elixir, documentation is a first-class citizen, and what I mean by that is that there are specific language features meant for documentation, and because of those specific language features, a lot of tooling can be built in and around documentation to generate web pages of documentation and also test based on the documentation. The primary location for all Elixir documentation is the website Hexdocs.pm. When you go here, you can type in Elixir and get the main page for Elixir core documentation. Starts right off with the kernel. We'll be using one of the functions from kernel. We'll also be using a function from float. We're going to solve today's exercise with what we know, but I find the solutions difficult to understand and makes Elixir look hard, but I promise you Elixir is much better. The trouble is that at our point in learning, we don't know quite enough to use Elixir idiomatically. So afterwards, I'm going to give you a sneak peek at how you would solve this more elegantly. It only takes 2 more concepts, and you'll know how to do this very soon. We'll use Google AI Studio again as our trainer. Let's see if the native audio dialog forms well again. Remember that system instruction I started out with where I asked Gemini to be my instructor or mentor? We're going to type that into a system instruction slot when we start up our chat this time. And we're going to enable the effective dialog setting, which will allow the model to respond with more tone and expression. Okay, so here we are in Google's AI Studio. We're going to pick Stream. We're going to make sure we have the native audio dialog model chosen. Here's the instructions I'm going to give it. It says, I'd like your help completing the Freelancer Rates exercise in the Elixir track on exercism.org. The exercise is teaching me about integers and floating point numbers and introduces us to the kernel and float modules. Can you be my instructor and mentor? So this is information that the model will get as soon as we start the session. We'll use a different voice. We'll see how that goes. We like turn coverage. We're trying effective dialogue. Let's go. Hello, Gemini.
Hello. I can definitely help you with that. It sounds like a great way to learn about integers and floating point numbers in Elixir. Let's start by opening the exercise on exercism.org. Are you ready to begin?
I am. I have the exercise open.
Great. Let's start by looking at the first function we need to implement, which is daily rate /1. Can you describe what this function is supposed to calculate for us?
The instructions say to implement a function to calculate the daily rate given an hourly rate. And it looks like they are suggesting that there are 8 hours in a day.
Exactly. So to calculate the daily rate, we need to multiply the hourly rate by 8. How would you write that function in Elixir?
I think hourly rate times 8.
That's absolutely correct. Now, the exercise also mentions that the return daily rate should be a float. How can we ensure that the result is a float even if the hourly rate is an integer?
Good catch. How about I multiply by 8.0?
Perfect! Multiplying by a float ensures that the result will also be a float. Now, let's move on to the next function, apply discount/2. Can you explain what this function should do?
Before we get there, I'd like to run the tests and make sure that we got daily rate correct.
That's a good idea. Let's run the tests to confirm that the daily rate/1 function is working correctly. What do the retests results show?
That we've passed. So yes, we can move on to task 2 now.
Excellent! Task 2 is to calculate a discounted price using the apply discount/2 function. The instructions mention that discounts are modeled as fractional numbers representing percentages. How would you implement the apply discount/2 function to calculate that?
I think this one's a little bit confusing because the discount they're giving you as a whole number like 10, not a percent and not a decimal number.
I see what you mean. The instructions clarify that the discount is a fractional number representing a percentage. So if the discount is 10, it should be treated as 10%. To apply the discount, you'll need to convert that number to a decimal and subtract it from the original price. How would you do that mathematically?
So I've taken the discount and divided it by 100 and then subtracted that from 1 so that I end up with the percent remaining and multiply that by the before discount value.
Okay, that sounds like a logical approach for calculating the discounted price. Have you had a chance to run the tests to see if it's working correctly?
So it says my tests pass, but I have a question for you here. It wants the answer to be a float, but I don't have any float values here. Why is this a float?
That's a great observation. In Elixir, when you perform division using the / operator, even if both numbers are integers, the result will always be a float. That's why even without explicitly using float values in your calculation, the result of the division will make the final price a float.
Excellent. Let's move on to task 3.
Wonderful! Task 3 requires you to calculate the monthly rate given an hourly rate and a discount. Remember to consider the number of working days and the discount as well. How would you approach this one?
So the instructions up here say that there are 22 days in a month.
Yes, that's correct. A month has 22 billable days. How can you use that information along with the hourly rate and discount to calculate the monthly rate?
So we could get the daily rate using the first function.
That's a good start. You can use the daily rate function. What else do you need to consider to calculate the monthly rate, keeping in mind the number of billable days and the discount?
So then we need to apply the discount to that answer and then multiply the whole thing by the 22 days. Is that right?
That's the right approach. So the monthly rate would be the discounted daily rate multiplied by 22. Go ahead and implement that formula.
I see. I did, but apparently, it says that it wants to always return an integer. So I think this is where one of the kernel or float library functions comes into play. Is that right?
You're right. The test is expecting an integer. You need to convert the final result to an integer. The instructions mentioned a function for that. Do you recall which one it is?
And it also should be rounded up. So we need a ceiling function.
Exactly. The instructions mention that the result should be rounded up to the nearest integer. You'll need to find a function that performs ceiling operation to achieve that. Look for a function in the kernel or float modules that does that.
So I think there are two ceiling functions, right? One in kernel and one in float. The difference being that the kernel function's ceiling returns an integer. Is that right?
Yes, that's correct. Kernel.ceil.1 will round a float up to the nearest integer and return an integer value, while float.ceil.1 returns a float. Since you need an integer result, kernel.ceil.1 is the correct choice. You can wrap your current calculation with that function.
All right, I've done that, and now our task 3 tests are passing. So we can move on to the final task.
Excellent! I'm glad that worked. Now, let's tackle the final task. What does it require you to calculate? Let's break it down step by step.
Right, so this takes a budget, an hourly rate, and a discount, and it wants to know the number of days that I believe that budget will cover. So we first need to calculate the discounted daily rate, I think.
That's right. You'll need to use the apply discount function you defined earlier. What would be the arguments for that function?
So I think similar to before, we first calculate the daily rate, and then we take that result and give it to the apply discount function.
Exactly. So you'll use daily rate, hourly rate as the first argument to apply discount, along with the discount. What should be the next step after calculating the discounted daily rate?
So then to know how many days the budget will cover, we need to divide budget by the discounted result.
Correct. You'll divide the budget by the result of applied discount. And what should be the final step according to the instructions?
It says it should be rounded down, so take the floor function to 1 decimal place. So that's a float answer, so the answer must be the float floor function.
Yes, you need to take the floor of the division result to round it down to 1 decimal place. How would you read the float.floor function for that?
So I've implemented float.floor, and then given the first argument is the budget divided by the discounted daily rate, and the second argument is 1 for the 1 decimal place.
That sounds correct. You're using float.floor to round the result down to 1 decimal place. Now, try running the test to see if everything works as expected.
It looks like everything passes.
Excellent! You've successfully completed the exercise. You've demonstrated a good understanding of using integers and floating point numbers and the kernel and float modules in Elixir. Great job!
Thank you. Thanks for your help.
You're very welcome. I'm glad I could help you with the exercise. Let me know if you need any further assistance with other exercises.
All right, now let's look at how we would make our previous solution more idiomatic Elixir, more elegant. I've added, remember I said there were 2 features we didn't know yet. We know def, that's how you define a function. There's def-p, that's a private function. We could have used public here, but then the exercise complains that the 4 public functions were the API, and so what we want is private functions. The other concept we didn't know about yet is piping. So the way piping works is it takes this value, the previous value, and makes it the first argument for the next function. So what this says is take the hourly rate and make it the first function, or the first argument to daily rate. That's the same thing as this code right here. But then, now that we have the daily rate, we're going to take that and make it the first argument to the apply discount function. Discount is the second argument. You see here, the apply discount takes the before and then the discount. So this takes the before as the first argument, and discount is the second. Now that we have that answer, we can say, what's the discounted monthly rate? So the discounted monthly rate takes that discounted daily rate and multiplies it by the days in a month. This is a little bit of a best practice about taking something that's a magic number, they'll call it, and putting a nice label on it so everybody knows what we're talking about. 22, if this was 20 days, I might have thought, okay, or if it was 31 days, I might have said okay, but this 22 to me is a strange number, so I thought it was clearer by calling it days in month. So now that we have the discounted monthly rate, we can then pass that result to be the first argument of the ceiling. So these two, line 17 with all of its nesting, is the same as lines 19 through 23. And the reason this function still passes tests is because the last referenced value, so that's the result of these functions here, is what's returned. So this actually gets calculated and ignored if we were to run this. All right, so then similarly down here in days and budget, we take the hourly rate, we make that the first argument to daily rate, we make that the first argument, that result the first argument to apply discount, same as before. Then I've added another private function to take the discounted daily rate and the budget and do the division. And then floor. So this reads much nicer than line 31. This takes a while to detangle, whereas this is laid out in a nice linear fashion. So this is a glimpse as to how Elixir code is more idiomatically written. It's clearer and easier to maintain. Well, I think the effective dialogue setting did add some emotion, punch, tone, more friendliness to the voice. I think it asked me constantly for what to do next because we asked for it to be our mentor. But there was a couple of cases where I wasn't sure it was reading the screen often enough or perhaps thorough enough. Still, I thought it did a pretty good job of understanding the exercise goals and shepherding us along. Join me next time for the secrets exercise where we learn about anonymous functions and bit operations.